Good morning, students. This is Latif sir. In this video, I am continuing the chapter 4 of class 8 chemistry. The topic is atomic structure. In the previous video, I have told that atom is made up of three subatomic particles: protons, neutron, and electrons. Protons and neutrons are present at the center of an atom, and together they are called nucleons. Protons and neutrons are present at the center of the atom, and which is known as nucleus. So proton and neutrons are present at the nucleus of an atom, at the center of an atom, and the electrons are revolving around the nucleus in different circular paths, and these circular paths are known as shell or orbit. Okay, so electrons are revolving around this nucleus in different circular path. Okay, so today first I will discuss about what is atomic number. Atomic number, which is represented by Z, and in simple word, atomic number is the number of protons present in the nucleus of an atom. Atomic number is the number of proton present in the nucleus of an atom of an element. Okay, and it is denoted by Z. For example, if two protons are present at the center of an atom of an element, then its atomic number is 2. Okay, if 3 protons are there, then atomic number is 3. Okay, so atomic number is equal to number of protons present at the in the nucleus. And you know that in an atom, number of protons and number of electrons are equal. So you can also say that atomic number is equal to number of protons, p plus means proton, or you can also say that atomic number is equal to number of electrons, because in an atom total number of protons is equal to total number of electrons. Remember that. That's why atom is always electrically neutral, because in an atom total number of protons present at the nucleus is equal to total number of electrons which are revolving around the nucleus in different circular path. Okay, so atomic number is generally number of protons, or you can also say atomic number is equal to number of electrons. Okay, for example, if in hydrogen atom only one proton is there, so atomic number of hydrogen is 1. In helium, 2 protons are present at the nucleus of helium, then atomic number of helium is 2. Okay, if 3 protons are present at in the nucleus of an atom, then atomic number is 3. Okay, like this. Now see what is mass number. Mass number of an atom, like atomic number, mass number, which is denoted by A, capital A. It is the total number of protons and neutrons at the in the nucleus of an atom. The sum of number of protons and number of neutrons. The sum of number of protons and number of neutrons in the nucleus of an atom is known as mass number. Okay, so the total number of neutrons and protons together known as nucleons. Nucleons means number of protons, nucleon means protons and neutrons. Total number of protons and neutrons are known as nucleons. Okay, so total number of nucleons, that is protons and neutrons, present in the nucleus of an atom of an element is called its mass number. So mass number is equal to total number of protons plus total number of neutrons. Okay, so you can also write total number of protons means atomic number, so mass number is equal to atomic number plus number of neutrons. Okay, so using this formula you can calculate number of neutrons also, because number of neutrons will be equal to mass number minus atomic number. Number of neutrons will be equal to mass number minus atomic number. For example, in case of magnesium atom, there are total 12 protons and 12 neutrons are present at this in this nucleus of magnesium. So mass number will be 12 plus 12, that is 24. Mass number of magnesium will be equal to 24, 12 proton and 12 neutrons in the nucleus, and 12 electrons are revolving around the nucleus of magnesium in different circular path, different cell. Okay, now see how to represent an element, with the help of atomic number and mass number. Okay, suppose an element is X and its atomic number is Z, then you have to write atomic number here and you have to write mass number here. Okay, for example, in carbon atom there are total 6 proton and total 6 carbon. In case of carbon, there are total 6 protons are present at the in the nucleus, and 6 neutrons are also present in the nucleus. So its mass number of carbon is 6 plus 6, that is 12, and its atomic number is 6 because 6 protons are there, and symbol of carbon atom is C. So the carbon atom, how to represent the carbon atom? You have to write the symbol of carbon C, and then you have to write the atomic number of carbon. Atomic number of carbon is 6, and the mass number of carbon is 12, 6 proton and 6 neutrons. So the symbol of carbon is 6C12. Okay, similarly for hydrogen, you can write for hydrogen, there are the symbol of hydrogen is H, and in hydrogen atom only one proton is present in the nucleus. And in simple hydrogen there is no neutron particles are present in the nucleus. So mass number of hydrogen, simple hydrogen, that is protium, is also 1. So what is the formula, the symbol of hydrogen atom is H, and its representation of one atom of hydrogen is 1H1. Okay, you have to write like this. Similarly for oxygen atom, in oxygen atom there are total what is the symbol of oxygen is O, and in oxygen atom total 8 protons are present in the nucleus, and in nucleus of oxygen atom, total 8 neutron particles are also there. So total number of proton and total number of neutrons, that is 8 plus 8. So atom mass number of oxygen is 8 plus 8, that is 16. So you have to write mass number here, atomic number here, and symbol of oxygen. Okay, so this is the representation of oxygen atom. Now see what is isotope. Isotope means if two or more elements having the same atomic number but different mass number, they are called isotope. Okay, in simple word, isotope of an element have the same number of electrons, that is same number of protons, atomic number is same, same number of protons and same number of electrons, but different number of neutrons. That is why the mass number of isotopes are different. So isotopes are elements, or isotopes are atoms of same elements having same atomic number but different mass number, having the same atomic number. For example, I am giving example. For example, isotope of hydrogen. Hydrogen has 3 isotopes: 1H1, which is known as protium, deuterium 1H2, and tritium 1H3. You can see in all these 3 isotope, mass atomic number is 1. Okay, atomic number is 1. That's why all these 3 are hydrogen atom, but their mass number are different. In protium mass number is 1, in deuterium mass number is 2, in tritium mass number is 3. So protium, deuterium and tritium are the isotope of hydrogen, and all these isotope of hydrogen having the same atomic number 1, but mass number is different, and their difference in mass number is due to difference in number of neutrons particle in the nucleus. Okay, similarly carbon has 3 isotopes. Carbon 6C12, 6C13, 6C14. Okay, in all these 3 isotopes of carbon, atomic number is same, atomic number is 6, but the mass number is different. In carbon 6C12, in 6C12 the mass number is 12, in 6C13 the mass number is 13, in 6C14 the mass number is 14. Okay, so in all these 3 isotopes of carbon, atomic number is same, that's why all these are the isotope of carbon. Okay, but their mass number is different, so all these are isotope of carbon. Similarly oxygen has 3 isotope, O 8O16, 8O17 and 8O18. Okay, chlorine has 2 isotopes, 17Cl35, 17Cl37. Okay, so isotopes, in isotopes are elements of isotopes are atom of same element, because they have the same atomic number, same number of proton in the nucleus, but the number, due to difference in number of neutrons particle in the nucleus, their mass number are different. Okay, isotopes, iso means same, topes means position. Okay, and isotopes of an element occupy the same position in the periodic table because they have the same atomic number, and they have the same atomic number, and they have the same chemical properties because they have the same atomic number, same number of protons and same number of electrons. Okay, now see what is atomic mass. Atomic mass, in simple word, atomic mass means mass of a single atom, but atom is very extremely light particles. In simple word, atomic mass means mass of a single atom. Okay, but actually atom is extremely small particle, so it is not it is very difficult to express, or it is very difficult to measure the mass of an atom in kg or in gram unit. Okay, so mass of an atom is generally measured in unified atomic mass unit. It is a unit of weight, unit of mass, and very small unit of measurement of mass of an atom. Okay, and it is equal to the 1 AMU or 1 U, unified atomic mass unit, is equal to 1.66 into 10 to the minus 24 gram. Okay, so mass of a single atom is measured in this unit, unified atomic mass unit, which is represented by U, and one unified atomic mass unit is equal to 1.66 into 10 to the minus 24 gram. Okay, and unified mass unit is defined as as 1/12 the mass of a carbon atom. So one unified atomic mass is equal to 1 unified atomic mass unit is equal to 1/12 the mass of carbon 12 atom. Okay, so the mass of the atom of any element measured in unified atomic mass unit, and it is called atomic mass. For example, atomic mass of hydrogen is U, 1 unified mass unit. Okay, atomic mass of oxygen is 16, atomic mass of carbon is 12, atomic mass of nitrogen is 14. Okay, now see electronic configuration. What is electronic configuration? Electronic configuration is the representation or is the arrangement of electron in different circular path of an atom. Electronic configuration is the arrangement of electrons in different circular path of an atom. Okay, in different energy level or in different cell of an atoms. Okay, so the distribution of electron in different cell around the nucleus of an atom is called its electronic configuration. So you have to study about the electronic configuration, how to represent, how to arrange the electron in different cell, different orbit. So you have to read the Bohr-Bari scheme. With this scheme, Bohr-Bari scheme, you can write the electronic configuration of element. Okay, so you have to follow some rules. First, starting from the nucleus, the cells are designated as KLMN cell and so on. And the K cell is the nearest cell to the nucleus of an atom. And K cell is the lowest energy cell, and it contains least number of electrons. And the energy of cell increases as we go outwards. And the maximum number of electrons that each cell can hold is based on the formula 2n square. So using this 2n square formula, you can calculate what is the maximum number of electrons in each cell. Okay, where n is the energy cell, number of energy cell. Okay, so according to this rule, this Bohr-Bari scheme, different cell around the nucleus are represented by K cell, L cell, M cell, like this: K cell, M cell. The first cell nearest to nucleus is K cell, then L cell, then M cell. Okay, and in each cell, maximum number of electron is measured, or maximum number of electron can be calculated using 2n square rule, where n is the number of energy level. Okay, and first you have to fill the lower energy cell. You have to fill the lower energy cell with electron, and then when the lower energy or cell or orbits are full, then electron will be accommodated in next higher energy level. Okay, and the outermost occupied cell of an atom is called its valence cell, and the electrons present in the valence cell of an atom is called valence electrons. And the valence shell of an atom cannot accommodate more than 8 electrons. Okay, this point you have to remember. The valence shell of an atom, valence shell means outermost cell, outermost occupied cell of an atom is known as valence shell, and valence shell cannot accommodate more than 8 electrons, and this is known as octet rule. Valence shell cannot accommodate more than 8 electrons. This is known as octet rule. Okay, now one note is given: in case of hydrogen and helium, only one cell is there, so they can accommodate maximum 2 electrons, and this is known as duplet rule and octet rule. Okay, hydrogen and helium, they can accommodate maximum 2 electrons in their valence shell, and this is known as duplet rule. Okay, so therefore electronic configuration of hydrogen and helium is 1 and 2 respectively, because they have only 1 and 2 electrons. So using this rule, you have to arrange the electron in different circular path or orbit. Okay, so according to 2n square rule, the first cell, that is n equal to 1, K cell, can accommodate 2. According to 2n square rule, maximum 2 electron can accommodate. The second cell, that is second n equal to 2, second cell can accommodate maximum 8 electrons. Third cell can accommodate maximum 18 electrons. Fourth cell can accommodate maximum 32 electrons using 2n square rule. And remember that the outermost cell cannot accommodate more than 8 electrons. The valence cell cannot accommodate more than 8 electrons. Okay, now see electronic configuration of lithium. Lithium has atomic number 3. So in lithium, 3 protons are there, Okay, and 3 electrons are also there. So in 3 electrons you have to arrange in different cell. In first cell 2 electrons, and in second cell 1 electron, because first cell can accommodate maximum 2 electrons. So you have to give 2 electron in the first cell, and the rest 1 electron you have to give in second cell, in L cell. Okay, so electronic configuration of lithium is 2 and 1. Okay, now see, in case of aluminum, atomic number is 13. So in aluminum 13 protons and 13 neutrons particles are there. So number of protons is 13, number of electrons also 13. So 13 protons, 13 neutrons are present at the in the nucleus, and 13 electrons are revolving around the nucleus in different cell. Okay, so according to 2n square rule, first cell can accommodate maximum 2 electrons. So far you have to arrange these 13 electrons in different cell. So you have to give first in first cell 2 electron, because first cell can accommodate maximum 2 electron. In second cell you have to give 8 electrons, that is uh, L cell can accommodate in L cell you have to give 8 electrons. Okay, so and rest of the 3 electrons, in first cell 2 electron, in second cell 8 electrons. So total 10 electrons you have arranged in K cell and L cell, and rest 3 electrons you have to give in the last cell, valence cell, that is M cell. Okay, so total 13 electron you have arranged, and the electronic configuration of aluminum is 283. In first cell 2 electron, in K cell 2 electron, in L cell 8 electron, and in M cell 3 electron. Now see electronic configuration of potassium, atomic number is 19. Okay, in potassium total 19 protons and 19 neutrons are there in the nucleus, and 19 electrons are revolving around the nucleus in different cell. Okay, so you have total 19 electron, you have to arrange these 19 electron according to 2n square rule. Okay, you know first cell can accommodate maximum 2 electrons, so in K cell you have to give 2 electron. In second cell, that is L cell, you have to give 8 electrons, because it can accommodate maximum 8 electrons. So total 10 electrons you have arranged. More 9 electrons are left. Okay, so in third cell you have to give, 8 electrons. Do not give 9 electron in third cell, although it can accommodate maximum 18 electrons. But remember that the valence cell cannot accommodate more than 8 electrons, so you cannot give remaining 9 electron in M cell. You cannot give the remaining 9 electron in M cell, because the valence cell or last cell cannot accommodate more than 8 electrons. So in M cell you have to give 8 electron, and the remaining 1 electron you have to give in N cell. So electronic configuration of potassium is 2881. Okay, so using 2n square rule and the points and the following points that given by Bohr-Bury scheme, you have to follow. Okay, to write down the electronic configuration. And thank you students, and next day I will discuss about valency.